Hello and good day to you. So this is probably going to turn into a bit of a strange rant. I built a stock market AI that made money on the historic New York Stock Exchange data from the Alpha Vantage API, and had a few nice 3 and 4 figure successes, and was often declining bad trades. The one below is a printout for the console of actually a very new neural network that's not doing very well. Given that that's my definition of not doing very well, I had a much better one where it was 80% accurate. The 20% where it wasn't accurate, it declined the trade. And it was the one that made a $1,000 transaction on the historic data. So that's good. I kind of intend to play around and try and use this for real in the new year. I'm doing a bit of a review of stock market data and trading literature at the moment to make sure I'm not doing anything particularly mad. The current logic for this video is to talk about optimization, because last week I got this running and that was a massive win that it actually ran, because I didn't think it would do, and now I've been trying to get it so it makes more money and it's more efficient and it's smarter. So an AI needs feedback to get better. Simple most cases for classification, it's up 1 for good, 0 for bad, and if you're doing a number regression, it's the number you want to prognosticate. But if you've got something a bit more complicated, like where the AI is playing a game, it's essentially moving between states, and you need to write an optimizer to tell it whether a given move between states was good or bad. Now, the other side of that problem is, usually in a game you don't know whether a given state change or a given action that you made in the game space was good or bad until you win or lose. And usually there's a bit of a long delay between making the action and getting that that feedback of reward or failure. Now, it's slightly simpler for me than playing chess. Chess AI probably couldn't manage to do at this point, but creating an AI to look at stock exchange data is relatively easy because it's got 2 states, buy or sell. So we want to give positive or negative feedback whether the state that it was in at the given point was the right one. So the problem we've got here is you're only really going to know whether a position was right or wrong much further down the line when you sell or buy the stock. So if you buy the stock and the price has gone massively down from when you sold it, that's pretty good. That's a short. And you want to reward the AI at that point to say that was the right choice and push it further into that behaviour and deepen that behaviour. The problem with that is you're only going to get a few chances of getting that feedback for the AI. It's not going to be common. An AI is only going to transact against the data, a given stock, a few times. It's not going to buy and sell a new stock every single day. So there's not a huge amount of cases where you can feed back onto that AI. And you might end up cycling through lots and lots of different stocks trying to train it. You've got this high likelihood of falling into suboptimal behaviours because of that. And that's to do with, if it kept on getting a 0 for bad and it kept on being told off for doing something that it done repeatedly, it might dumb down a whole load of behaviours that it was doing previously, and not just the thing that was causing it to make the mistake. Because if it kept on getting the negative feedback and no positive feedback because it was completely it was completely wrong. Basically, you could train your AI not to play the game, and I think that's relatively surprisingly common, of where either the optimization is written badly or the game isn't represented to the AI very well and all sorts of things, and the AI just decides not to play. So the manual optimizer I wrote was a set of rules for whether the AI did a good thing or a bad thing. Market traders often talk about people trading perceptions of risks and a conception of value. It's often a common mistake for people that they believe what traders are doing are buying a stock because they know that it's going to go up, and that they know that the future's golden for this stock because that company is just fantastic. That's not what happens. Somebody buys a stock because they think the price of that stock is low, or the price of that stock's too high and is going to fall, or they're going to make money somehow out of that way. So you're not predicting the market future. What people are transacting against is the predominant perceptions that drive supply and demand. Now, there is in a market a bottom level of support for a given price usually. So if somebody said, here you can buy an Apple share for $10, everybody will buy it at $10. Nobody will buy it for $1,000, and somewhere in between is most people. Was everybody. So between those two extremes, there's going to be a whole range of different behaviours, but there's a minimum value where that stock just becomes a bit of a bargain. So you're willing to buy that stock for that price. So there's a minimum support within any market for a given price, depending on how many people are taking part of that market. That means often the signals within a trade bounce up and down off the ceiling and a floor, and then there's a breakout point where either it falls past the floor or falls above the ceiling, and there's a shift in the market because the number of people buying has forced there to be that the price goes up because there's so many people interested in that particular stock that it gets driven up. And that's what they talk about as trading signals, and there's a whole variety of them, and that's what we're trying to train our AI to look for in the market. It's receiving the data as a whole bunch of noise, and its job is to see through that noise and spot where the trading signals are. Now, for my first AI that I've written, the one that I've talked about previously, where it's doing quite well on the New York historic data, that is getting feedback just based on, did it do a good thing? Did it home in on a signal that routinely gives it money? And the word here is routinely, not maximum money. So it's not driven to work out the best process. It's just driven to look for signals in that data which reliably tell you that the market is turning one way or the other, that the ceiling, it's gone past the ceiling, or that it's fallen past the floor, to use our previous metaphor. And if you go and talk to traders, they will talk about judgment heuristics, and this is a very complicated judgment heuristic essentially. I have set a judgment heuristic here of find me in the data the signal which most routinely represents the market is turning one way or the other based on the historic data, and I intend to apply it to the future data for the New York Stock Exchange, and I'm essentially, my view of the future market is it's going to continue to behave like the past market, And somebody out there is probably sniggering at this point, thinking that's not going to happen. But, those who don't learn from history are doomed to repeat it. So it's still a good place to start. And if you're not going to look at the past for ways to judge the future, what else are you going to do? So it's the best thing to do, but it's got its flaws. My final point that I'm playing experiments with at the moment is that was a reward system I wrote. That optimizer was a set of rules that told the AI when it did a good or a bad thing. The AI is when it's trained is combing through the market data, looking for the trading signals, and it's been given a bunch of information to help it spot those trading signals. But it's still random how it learns those trading signals. Like it basically finds a thing that worked once and then repeatedly does it until it stops working, and then maybe if it's lucky, it learns something else. If it doesn't, it might fall into a really suboptimal problem state. It might fall into a state where just buying and selling randomly. And I don't really want that. So my next step is to work out if the way of training the AI can be improved, and instead of having a optimization system that I wrote, which, thank you very much, it was doing very well, thank you, but I want it to be a reward system that the AI learns itself, which would cause us a bit of a scary thought with that there's no longer any judgment heuristic there. There's no longer any perception of the market that's going on. It's just an AI trying to find a solution to several different mathematical functions in tandem, which in theory might create money, which becomes interesting as a concept because it probably undermines the idea of why do we trade on a market, because there's no perception that we're discussing. Anyway, back to topic. So this is called QLearning. So the reward system for the AI can be thought of as a mathematical function. Anytime that you've got a mathematical function, you can represent and abstract it with an AI or neural network. What you then get is an AI teaching another AI. The reward AI receives the sparse reward signals that the other AI would have got, and continue to change the child AI based on what it's learned as an interpretation of those reward signals. So over time it will get more and more exact with its reward signal to the other AI, but the child AI is continuously learning. Then it's no longer a sparse learning process. The child AI is running through every day, and every day it gets a simulated reward from its parent AI of what it thinks it's how well it thinks it's doing. Now this can be a bit compared to how the brain works with, you've got a representation of your imaginary world of whether you think if things are going good and bad, and if you're doing good, your brain tells you you're doing good. This has led to a really intense and long training AI, which I haven't got to the bottom of whether it's worked. So this video is probably a little bit disappointing, because what you'd want to hear is me going, I did QLearning, it's fantastic, you should follow it and do and go and buy these books. I can't tell you at this point, because I've built one. It looks to work. I'm not entirely sure whether it's perfect. Also, using an AI to train another AI, the teacher AI can be seen to look at homework and answers that you just can't give to the first AI. So the teacher AI is actually able to look ahead into the future and give an assessment of really how well the child AI is doing and give it feedback in that way. My worry here is it's no longer a judgment heuristic. I have no idea what it's really doing. It's completely AIs teaching AIs. There's a joke, I think, on the internet of, we put an AI in your AI. Two good things added together don't always add up to being a better thing. So it hasn't yet built my manual optimization process. It hasn't really, the QLearning method hasn't demonstrated itself better, but I kind of have noticed with the handwritten optimizer I wrote, it seemed to hit a wall, and I don't know whether it hit a wall because that's the best it could do, the best you could do based on the market signals that I'm looking for. You can't. There's sometimes you can't make something more complicated than it is. So the final point would be I might try some commensurate neural evolution to try and evolve these things, but I think that's probably too complicated for where I'm at the moment. There it is working. That's its first epoch. It didn't make much money based on its it had to buy the stock. Never with these AI. I mean, I have to clarify when I say these AI make money. They never get their stock for free. They have to be called a success. They have to take the value of the stock, and either the value of the stock double over time, or them short it so much that they've made more money than was put into the investment. But it made a profitable trade. So the first instance of it, takes a stock, sells it off, made a little bit of money and walked away with it. So there's reason to be hopeful that the QLearning method might be useful. I'm somewhat doubtful, and that's my video blog for discussing my misadventures with optimization and neural networks. I hope it's been entertaining. It's probably a bit of a dry subject, and I'm hoping you'll like and subscribe. Bye.